Afternoon. I'm Spot On Weather meteorologist Matthew Euler. Welcome to my latest video. This one is going to be on La Nina winters. Of course, La Nina being in the forecast for this upcoming winter, I wanted to start examining some of these winter type topics as we prepare. We're working hard here to develop the new winter forecast, and this is just one of those factors that we look at when we do develop the winter forecast. So we're going to go into La Nina winters. I may not get through all of these slides in just one presentation. I may need to divide this into two parts. So I might go through the year 2017-18, that winter in particular, and then finish up with part two after that. So let's go into the overview of today's video. We are going to look at past La Nina winters, and I'm only going to go back to 2010. Now, why am I limiting my sample size here? Why you're probably asking, why don't I go back further than 2010, right? Get a larger sample size? Completely understood. But what I believe really firmly in is things have drastically changed really since 2010 as far as these warmer winters go. And to me, when you compare any of these teleconnections, La Nina or El Nino included, what worked before with La Nina, El Nino may not work the way it used to based on the warming oceans. So what I'm doing is I'm doing a more limited sample size here, and I'm only going to go back to the 2010 winter. We're going to examine in each of the La Nina winters since 2010, we're going to look at temperature anomalies, we're going to examine the precipitation anomalies, and then I will also show you the 500 millibar height anomalies. And then in addition to just simply La Nina being established for the respective winters, we'll take a look at the teleconnections, the other teleconnections during those specific winters, those teleconnections of note. And then at the very end of this training video, I will show you the NOAA forecast for this upcoming winter. So if we look at past La Nina winters, this is a great slide here because it breaks things down nicely, okay? You'll notice over here on the far left, we have all the different La Nina winters. I believe it's a sample of 25, sample size of 25. Of course, I'm not going to go back as far as, before 2010 on these, but I wanted to show you over time the different categories of these La Ninas. We've seen 12 weak La Ninas, we've seen 6 moderate La Ninas, and then we've seen 7 strong La Ninas. And by the way, these graphics are courtesy of Jan Null, CCM Golden Gate Weather Services. That's where I pulled these charts from. Now, you may ask yourself, okay, well, there's weak, moderate, and strong La Nina categories. Now, what constitutes each of these? That's why I threw this in here at the bottom of the slide. A weak La Nina has the water temperatures running 0.5 to 0 0.9 degrees Celsius below normal in the Nino 3.4 region. For moderate La Ninas, your water temperatures are running -1 to -1.4 degrees Celsius in the Nino 3.4 region. And then for strong La Ninas, we're talking about 1.5 degrees Celsius or colder for strong La Ninas, okay, for those water temperatures. So this is a classification. Overall, if we go back to the 1950s here on the chart here, or this graphic here on the left, you can clearly see that our weak La Ninas, we had 12 of those of the 25. We had 6 moderate La Ninas, and we had 7 strong La Ninas, okay? So if you look at the weak as compared to the moderate, we have about a 2-to-1 ratio, 12 weak to 6 moderate. And then we had just a little bit more than that as far as the ratio is a little bit greater when we talk about weak La Ninas at 12 and strong La Ninas at 7. But these are the various winters in which these various La Ninas occurred. Now the graphic up here in the upper right shows La Nina conditions when you see the blue coloring with these values with the minus sign in front. These are your water temperature anomalies in that Nino 3.4 region. Now SL You have SL, you have ML. This is a strong La Nina is SL, a moderate La Nina is ML, and a weak La Nina is WL. That's how these ENSO types are categorized, okay? Whenever you see the red lettering or the red numbering in here, that's indicative of El Nino conditions, okay? So this chart at the top kind of gives you a breakdown of the years. This goes back to the 2010-2011 winter season, which that's what I'm using in this presentation. And as you can see, from 2010-2011 winter right on through the past winter, 23-24, you can see the blue numbers here when we had La Ninas. We had La Ninas in back-to-back winters, 2010-11, 11-12. We had another La Nina in 16 and 17. We had another La Nina in 17-18. And then we had 3 straight La Nina winters from 2020 to 2023. And you can see these values represent varying degrees of water temperature anomalies in that Nino 3.4 region. All right. Over here in the bottom right, I'm also showing you generally some additional data here, kind of just breaking down where we saw La Nina conditions and where we see El Nino conditions. All right, moving on. Let's start examining some of these winters now, going back to 2010-11. Let's look at the temperature anomalies first. These are mean temperature anomalies, okay? So we're just looking at the average temperature anomalies each month. In each of the following slides, I have December will be your far left graphic, January will be the middle, and then the far right graphic will represent February in each of these winters that had La Nina conditions. So the winter of 2010-2011, we had a strong La Nina in place. Look at the December temperature anomalies of 2010. The purple coloring here, we're looking at mean temperature anomalies on the order of anywhere from 9 degrees Fahrenheit all the way down to about negative 15 degrees Fahrenheit. So this is purple indicates a very significant below normal situation as far as temperatures go. And you can see the purple colorings across the mid-Atlantic, Ohio Valley, southward into Georgia, the Carolinas, and Florida. The green coloring also indicates below normal temperature anomalies. It's not as significant as the purple coloring. And so you see the green coloring here, that's generally 4 to 8 degrees Fahrenheit below normal with this green coloring. So anywhere east of the Rocky Mountains in December 2010 during the strong La Nina really had colder than normal temperatures. And this is very rare anymore in December to get these kind of cold temperatures, okay, for the whole month. The reddish coloring or maroon coloring indicates warmer than normal temperature anomalies. So you can clearly see in December 2010, it was warmer than normal across the Four Corners region, Utah, Colorado, Arizona, and New Mexico. Now, look over here in the middle. We have January of 2011. These are the temperature anomalies for that particular month of the 2010-2011 winter season. We have a lot of blue and a lot of green, right? So that indicates well below normal temperature anomalies for January across much of the United States. And then over here on the far right, notice now the mid-Atlantic and southeast have warmed up. So that peach color indicates 1 to 3 degree Fahrenheit above normal temp anomalies by February of 2011. And the cold shifted further west towards Montana and southward in that particular winter. So to characterize the strong La Nina winter of 2010-2011, we had a very cold December and January across the mid-Atlantic and the east as a whole. Looking at the precip anomalies for the same winter, over here on the left is December. Remember, the middle will always be January, and then the far right graphic will always represent February. So the strong La Nina of 2010-11 precip anomalies, green wetter than normal, brown drier than normal, okay? So it was very much wet and above normal across Southern California, Southern Nevada, and Utah in December 2010. It was fairly drier than normal up and down the East Coast. And then over here in the middle, we have things kind of turned around there in California, Southern California, Nevada, and the desert Southwest. By January 2011, it was well below normal as far as precip goes, above normal in the green across the northern plains. And then over here on the far right is February of 2011. The mid-Atlantic overall, the winter of 2010-11 was fairly dry. I mean, you can see the brown coloring across the mid-Atlantic each of these months. Looking at the 500 millibar height anomalies now for that strong La Nina of 2010-11, look at this color. This bright orange represents upper level height anomalies that are positive. So we had very strong anomalously high height anomalies in December 2010 across Greenland and into parts of northeastern Canada. And then we have the blue coloring beneath it here in the 500 millibar height anomalies. This means below normal height anomalies. Now, below normal height anomalies are typically associated with colder than normal temperatures, and this reddish, orangish color, the maroon coloring, indicates above normal temperatures associated with anomalous ridging. So in December of 2010, we had an anomalous ridge. We had troughing along the east coast into the mid-Atlantic. That troughing, this blue color, went all the way across to the Atlantic to Europe. This is a really great pattern if you want snow and you want cold across the mid-Atlantic, when you get the upper level higher heights generally to the north over the lower heights to the south. This is a great pattern. Now, if you look over here in January, in the middle, January 2011, we still see those blue colors showing up across the eastern US, the mid-Atlantic, right across the Atlantic, into parts of Western Europe. And we still have that anomalously high height center, generally located over southern Greenland at this point in January 2011. And then we have a nice upper level ridge there into the Gulf of Alaska, into the part of the Bering Sea as well. So below normal heights continue in the blue coloring here, January 2011. And then over here on the far right, we have February of 2011. Now that upper level anomalous high heights has finally relaxed. You don't really see those bright oranges and maroon colors now over Greenland anymore. And you also notice how the blue shading across the mid-Atlantic and the east as a whole has gone away. What about other teleconnections in the strong La Nina winter of 2010-2011? Well, I tell you what, that North Atlantic Oscillation, the NAO, we talk about it a lot on this channel. Look how it dropped so sharply negative here. Okay, so despite the fact we have the strong La Nina and the cooler than normal water temperatures across the equatorial, eastern, and central Pacific, we also have this very strong North Atlantic Oscillation. All right, and I think I've got an example of, no, I don't have the NAO, but I'll show you an example of the AO here in a minute. What I want to get after here is when we have a strongly negative NAO is when you get these very strong anomalously high heights over the higher latitudes to the north, and beneath those you typically get that troughing condition, those troughing conditions along the mid-Atlantic and east coast. And so this is not a surprise. Look where this blue line dips down to. This was at the end of 2010, December 2010. And when this thing started rebounding right here, this blue line started going back up. That's when Southeast Virginia, Hampton Roads got hammered with a very, very big snowstorm just around Christmas Day in 2010. And that storm went all the way up to New York, and it really, really dumped a lot of snow. Now, what about the AO, the Arctic Oscillation, and the strong La Nina winter of 2010-11? Look at the blue vertical bars here from December 2010, mid-December, all the way through late January, really. Look how sharply negative the Arctic Oscillation is in this particular winter. You can see how far down these blue bars extend. The values are over here, by the way, on this vertical axis. So you see the negative values here in association below the zero line associated with a negative phase of the AO, strongly negative AO. What happens when you get a negative AO pattern? Well, you basically open up the freezer door, so to speak, and a lot of cold Arctic air comes down into the United States rather easily. You get a lot more East Coast storms with a negative AO. You got the upper level ridge and the anomalous high heights across Greenland. You get cross-polar flow to develop, sending those very, very cold temperatures southward into the United States from Canada. And then, the Hudson's Bay polar vortex, it can shift into a position which delivers Arctic chill. This polar vortex can shift down around the Hudson Bay area and really, really bring in some very, very cold air into the U.S. And then one other thing to mention here, again, with a typical negative AO pattern, you have an increased risk for these East Coast winter storms or these nor'easters in the pattern. All right. Additionally, let's examine the polar vortex, okay? So the strong La Nina 2010-11 winter season, what happened with the polar vortex? Look at the coloring here. This peach coloring and these deep reds. What this is showing is that we have a connection between the troposphere, the layer of the atmosphere we live in here at the surface, and the layer immediately above that troposphere, the stratosphere. And whenever you see these peach colors and these maroon colors reaching the ground, that indicates there's a lot of energy being transferred. There's coupling from the troposphere to the stratosphere, back to the troposphere, and that is going to result in a weakened stratospheric polar vortex, okay? And that is going to result when that drips all the way down to the surface right here in December and January of that year. That is going to allow for this Arctic oscillation in the troposphere to really tank negative, okay? Again, this is all favorable for winter weather across the mid-Atlantic and the eastern U.S. What happened that winter in Hampton Roads cities of Virginia? My goodness. It was one of the biggest snow years for the area in the winter of 2010-2011 across Hampton Roads. 21 total inches of snow fell for that winter season. All right. And specifically the storm around Christmas. This was the big snowstorm. It started snowing on Christmas night across Hampton Roads cities in southeast Virginia. These were some of the photos. Look at the photo here on the left of just all the snow. What a beautiful winter looking scene here. Over here on the left, this was courtesy of Brian Walker, this photo, and just it's a beautiful picture of winter. Look at the middle diagram here. This occurred during that strong La Nina winter of 2010-2011. Look at the blue coloring here. And it goes all the way up to Jersey, Long Island, including New York City, parts of western Connecticut. This thing was a monster storm that developed in late December 2010 during that strong La Nina winter season. You can see the blue coloring here. That indicates 10 to 20 inches of snow wherever you see this blue coloring, including southeast Virginia, the far northeast portions of North Carolina, and even look at the white coloring represents 4 to 10 inches all the way down to South Carolina. So this thing was a beast. If you look at the surface analysis over here on the right, during the storm, my, oh my, oh my, this was a really good snowstorm. You see a 990 millibar low pressure system here. This is a fairly intense low pressure. You see this red dash line indicates your warm front extending to the northeast. Got the cold front extending southward across the open waters of the western Atlantic. Very strong winds. All this overrunning, just running right into northeast North Carolina and southeast Virginia. A lot of overrunning here. And you're getting hammered with just a very big snowstorm with that particular case. So 13.4 inches of snow was recorded at the Norfolk International Airport on the 26th of December 2010. Just phenomenal. Like I said, the snow began on 25th of December, Christmas night, and it lasted through the 26th of December, and it was coming down hard. Unfortunately, I missed this one. I was back in the Midwest enjoying multiple snowstorms there, so I wasn't completely cheated out of a nice snowstorm, but this was a pretty good snowstorm for Hampton Roads cities, and it occurred during a strong La Nina winter. Now let's move on to the moderate La Nina of 2011-2012. These were the temperature anomalies. Again, on the left is December, center is January, and right is February. Look how much warmer things were for the winter of 2011-2012 across the eastern U.S. as a whole. I mean, December, you're running 3 to 5 degrees Fahrenheit above normal all the way up the East Coast. In January, almost the whole United States was above normal. 9 to 10 degrees Fahrenheit above normal across North Dakota into western Minnesota. And then over here on the right, we have February. Again, a very mild month across the east. There wasn't a whole lot of Arctic air that we were dealing with during the moderate La Nina of 2011-2012 winter. We look at the precip anomalies for that moderate La Nina winter of 11-12. Dry again from the southeast coast up to the mid-Atlantic coast. We had dry conditions for January in 2012 as well up the East Coast, and we continue to have those dry conditions. I mean, it really didn't end up very wet at all that winter. The green indicates where you have your above normal precip. So many of you across California were also very dry in that moderate La Nina winter of 2011-2012. What was going on at the 500 millibar level during that winter season? It's almost like a reverse of what we saw in 2010, 2011. In December here, the 500 millibar height anomalies, upper left. Notice the yellows and the orange coloring indicate above normal height anomalies at 500 millibars. Look where the blue coloring is. It's up across Alaska and in the high northern areas across the Arctic. So all the cold air pretty much stayed up over the Arctic the whole entire winter in 2011, 2012 winter. Look over here in the middle. This middle diagram here shows January of 12, yellow coloring on the eastern seaboard again. That's above normal heights. Above normal heights are associated with dry and warmer than normal conditions. Look over here on the far right. That yellow area is still there, the yellow coloring right from the Midwest to the East Coast up to New England. This was just not a very severe winter at all for the Eastern Mid-Atlantic. This goes to show you how the pattern can completely flip. Now, this was a back-to-back La Nina situation. 2010, 2011, we said was strong. Then the following winter, we still had La Nina conditions in place and it was moderate. What were some of the other teleconnections? What was the NAO like in that moderate La Nina winter of 2011-12? Look how positive this red spike indicates a positive phase of the NAO, all right? And that means the coldest air is going to stay locked up over the Arctic areas. What about the Arctic oscillation of the moderate La Nina winter of 11-12? Similar. Red. Look at this red spike here. December 2011, right on through the winter. This was positive, okay? Positive Arctic oscillation. That's going to mean milder conditions for the mid-Atlantic. Here's your typical positive AO pattern. Much, much different. Now we got the whole U.S. pretty much flooded by some of the milder Pacific air when we have a positive AO pattern. The polar vortex remains strong and it keeps that Arctic air locked up over the Arctic areas. The jet stream is pretty much west to east in a zonal fashion. And so you just get milder Pacific air to flood the entire U.S. Again, the coldest air and the stormiest conditions remain well to the north. Let's take a look at the polar vortex now, the amount of energy that was dripping down, and look at the blue coloring in December and January that I have here in the circled area. Completely different than the 2010-2011 winter season. So we are not getting what we need here at the surface from polar vortex is strong, and the Arctic air again is going to remain up over the Arctic areas. And then look what happened in 2012. These were the La Nina little snow years for Hampton Road cities in Virginia, and you're on there, 2012. You made that list. Very little snow that winter. Let's now move ahead to the weak La Nina winter of 2016-17. This is temp anomalies over here on the upper left for December. In the middle, this is January of 17 in the middle, and then February of 17 on the right. So December of 16, it started out like many La Nina winters where, it's not like way above normal in the mid-Atlantic and east in December. It was near normal across the mid-Atlantic up to the east, up the New England area. It was below normal slightly in the Midwest, and it was much below normal across Montana, parts of Wyoming, and the western Dakotas in December of 2016. Now, January of 17, look what happened. The coldest air was locked up over the Pacific Northwest, and everywhere east of the Rockies in January 2017 had this orange coloring of these deeper reds, deeper orange and maroons. This was well above normal, these temperatures in January of 17 with the weak La Nina now. And then over here on the far right is February of 17. Look how much above normal things are in this brown coloring across the Midwest. Just insane. The only below normal area was Washington State in February 2017. And again, this was during a weak La Nina winter. And then these were the precip anomalies in that weak La Nina winter. Brown, drier than normal. Okay, so December was drier than normal across the Mid-Atlantic, Virginia up to Southeast PA, New Jersey, Massachusetts, Connecticut, Long Island. It was also drier than normal across the Midwest. And then in January, it got really wet across California with the trough out in that direction. Near normal precip in January of 2017 for Virginia, and I remember this one across Hampton Roads. We actually did get an accumulating snow event in January. It wasn't a big snow, but there was a snow accumulating event here. And then over here on the far right in February 2017, look how the browns just invaded from the Midwest to the East Coast, just southeast to the Florida, to the Gulf Coast. Completely drier than normal in those areas. The wetter than normal conditions extended from Central California northward up to Oregon and Washington, as well as Idaho, Wyoming, parts of western Montana. Here were the 500 millibar height anomalies in that weak La Nina winter of 16-17. December 16th is unavailable, unfortunately. I couldn't get that. The website just wasn't loading it. But January of 2017 is here in the center. Look at the yellow coloring here. This indicates above normal height anomalies associated with dry and mild conditions. The blue shading indicative of below normal height anomalies with cooler and wetter than normal conditions. So really, I mean, you can see where the wetter and cooler than normal conditions were in January of 17. They were across the Pacific Northwest, and that's about it. Over here on the right, we see the continuation of the yellow colors, these higher than normal height anomalies from Southern California across the Gulf Coast and the Mid-Atlantic up to the Midwest. Whenever I see a pattern like this really makes me think that we got more of a zonal west to east jet stream, and much of the U.S. is just flooded with some milder air in February of 17. Now, what about the weak La Nina winter of 2017-18? What were the temperature anomalies like in this winter? Well, December was slightly cooler than normal for the Mid-Atlantic. It was much more colder than normal with the green coloring across New England area, Maine, New Hampshire, Vermont, Massachusetts, New York State, as well as the upper Great Lakes area was well below normal in December of 2017. The warmer than normal temperature anomalies were out across the Four Corners area in the western U.S., Nevada, and California. In January of 2018, this was a very interesting month. Look how all the green generally expanded from South Texas along the Gulf Coast up the Carolinas, Georgia, and Virginia. This was well below normal this month. Now, this was a pretty good start to the year across Southeast Virginia. It was a frigid start to the year, actually. I remember this. We don't get a lot of those anymore. There's many cases where New Year's starts off in the 60s near 70 degrees for a high anymore. All the warmer than normal temperatures were strictly across the western U.S. in January 2018. I'm going to show you a major winter event here in a moment for Southeast Virginia from this winter. Keep in mind, it was a weak La Nina winter too. By February 2018, though, my goodness, what happened here across the Mid-Atlantic and the East, all the way up to New England. Gulf Coast, Florida, all the way to New England, completely above normal, well above normal, where the colder than normal temperature anomalies were across Montana, on the order of 15 to 18 degrees Fahrenheit below normal there. Look at the precip anomalies. December here on the left. No surprise here. Pretty much below normal precip for the western U.S., California, Nevada, Arizona, New Mexico, Panhandle of Texas, Oklahoma, Kansas, up to Iowa, Missouri, Illinois, across to Indiana, and then drier than normal across the Mid-Atlantic, extending northeastward towards Pennsylvania, New Jersey, New York State, New York City, as well as Massachusetts, Connecticut, Rhode Island. Look at January. In January 2018 here in the middle, there was a slight green tinge over here across Southeast Virginia and eastern North Carolina, and that was mainly due to a major snowstorm. I'll show you what that looks like in a minute. Well below normal precip, meanwhile, across Texas and parts of New Mexico and Arizona. And over here on the far right shows precip anomalies in the weak La Nina winter of 17-18. It was well above normal. Look at this green coloring from eastern Oklahoma up through Arkansas, Missouri, Illinois, northwest Indiana really got a lot of precip in February of 2018. And that extended northeastward towards Ohio, Pennsylvania, into parts of southern New England. Drier than normal from southeast Virginia right along 95 down to Florida. All right, here were the height anomalies for the weak La Nina winter of 17-18. Here's December on the upper left. Really, it looks mainly like a zonal west to east jet in this situation. We did have higher than normal height anomalies across the western U.S. in December 17. We also, in January 18 here in the middle, we still had above normal height anomalies as well, extending across the Mid-Atlantic to New England, and along the southern U.S. as a whole, which is quite common during La Nina. And then over here on the far right, we have February 2018. We still show fairly mild conditions in association with these slightly above normal height anomalies from the southern U.S. up to the Mid-Atlantic and New England. Now, what were the other teleconnections like during the weak La Nina winter of 17-18? Well, look at this. Whoa! Look at this red spike here in 18, 2017 into 18. Really, most of 2018 had a strongly positive North Atlantic oscillation. And that's really not going to get winter weather in here when you get the strongly positive NAO. The Arctic oscillation, on the other hand, also matched up and was positive. You see the red spikes here. And that was also strongly positive for pretty much all of 2018. And then what about the polar vortex, the stratospheric polar vortex? Was there coupling between the troposphere and stratosphere? You did see a little bit of the peach color reach the surface in late December of 2017, indicative of a potential weaker stratospheric polar vortex at this point. And then you also saw another area. I remember this winter specifically, and it went right into March. There was weakening of the stratospheric polar vortex on multiple occasions. You see where these pink areas are: December, early December, late December, and then also into January. That polar vortex weakened. This, by the way, is courtesy of Simon Lee. So what happened at Hampton Roads in the weak La Nina winter of 17-18? We got a big amount of snow in January of 18, despite the fact we had a La Nina winter going on, which normally La Nina winters here in the Hampton Roads area are warmer and drier than normal. But look at this, I circled it here. We're looking at the top 10 list for Norfolk, Virginia for snow data. And look at January, the month of January. Okay, so we got 13.1 inches of snow in the month of January 2018. Simply impressive. It was the fourth snowiest January on record at the Norfolk Airport in 2018 in January. It was a big month for snow. Now, if we look at what happened during this event, what we had a major one of these bomb cyclones really go off. It started off down here off of Georgia, and as it moved northeastward, the dynamics in the upper atmosphere just allow for rapid intensification of this thing. It almost looks like it's a hurricane right at this point. It almost looks like we have a center with an eye here that's sort of cloud free. This thing was a beast, and it dumped snow in early January 2018 from Georgia northeastward into South Carolina, North Carolina, Virginia, up to Maryland, up to New Jersey and New York. I mean, this thing was a beast. And you clearly could see the comma shape of this thing. Just impressive looking storm and satellite. I got this one framed. This satellite image is framed in my house, everybody. I just love looking at it. Now, in the center here showed the actual storm track. This extratropical low pressure area developed east of Florida, and then this is the track of it as it went up the coast. See how it remains far to the east offshore of the mid-Atlantic? It wasn't too far offshore. It wasn't too close either. It was the ideal storm track to get a heavy snow into southeast Virginia and eastern North Carolina. And as it continued to move northeast on this track, it just got stronger and stronger. This graphic here on the right shows blizzard warnings in red coloring. All right, blizzard warnings for Virginia Beach, for Hampton Roads, Norfolk, down in the eastern portions of northeastern North Carolina, parts of southern the Delmarva area, into parts of Jersey, Long Island, all the way up the coast into Maine. This thing was just a beast. Now, the lighter pink is the winter storm warnings. The purple is the winter storm watches. So you can clearly see how much of a major coastal storm this actually was. This was the total snowfall from the January 35th, 2018 blizzard. Orange coloring on here indicates snow anywhere from 12 to 18 inches. Well, the lighter orange is 8 to 12 inches. And then as it went northeast, it just bombed out. Boston, you received 12 to 18 inches out of this. And then up in northern Maine, my goodness, you got 18 to 24, in some cases, excess of 24 inches, over 2 feet of snow with the January 2018 blizzard. This was just a nice view of, this was taken down in northeast North Carolina, by the way, here, this beautiful winter-like picture here on the bottom right. So we had 10.3 inches of snow recorded at the Norfolk International Airport on the 4th of January 2018. Leading up to this storm, it was frigid out. Let me tell you, it was very, very cold start to the new year in 2018. That very bitterly cold air mass preceded the storm. It lasted about 3 to 4 days out ahead of the snow falling. All right, that's where I'm going to end part one of the video. I am going to kick off part two. I'll have to get that one knocked out as well. And we're going to kick that one off with the last three La Nina winners, which started in 20 and 21. We'll go into 2021 winter. We'll look at that. Then we'll look at 21, 22, and then 22, 23. We had back to back to back La Nina winners in this case with varying degrees of intensity. One thing I'm hoping you're learning from the video is, there could be La Nina conditions in place, and it would favor dry and mild conditions for Mid Atlantic, but it doesn't necessarily mean you're not going to get accumulating snow events, specifically in southeastern Virginia and northeast North Carolina. It's very possible. You have to examine in conjunction with the ENSO phase, La Nina in this case, what were the other teleconnections doing? What were they looking like? Were they working with a La Nina type winter pattern or against it? And then look at the 500 height anomalies. What was going on with those? No La Nina winter is ever exactly alike, and you could have some weak La Nina winters or moderate La Nina winters or strong La Nina winters where it's completely mild and dry across the mid-Atlantic and the eastern U.S., and you could have others the same classification or category, weak, moderate, or strong, and be completely opposite because we have these other teleconnections in here that can really, really throw a wrench, so to speak, in the atmosphere. And yeah, so I hope you enjoyed this presentation. I mean, this thing was like 51 slides. I'm not going to go that long. But I hope you enjoyed the presentation at this point. We will kick off with this one right here, Moderate La Nina winter of 2021. When I come back and finish the recording of the video, just some good food for thought here with teleconnections. They've changed, okay? I'm a big believer in this. They've changed. You're not going to get the same effects of an El Nino or a La Nina winter back from 1982 as you are today, 40 plus years later, because the oceans have warmed so drastically, and it's just the temperatures just keep going up and up and up with each passing year. So the effects are different now as compared to 40 years ago, as an example, when we had a cooler Earth. But anyway, that's all I got for now, everybody. Until next time, take care and God bless everyone.